making some graphs. So draw this graph to the best of your ability. Yes. Call it f of x. I'm going to try to graph with you the derivative and the second derivative. So, let's see. What would I be graphing on the derivative graph from the original? I can't really graph the second derivative until I have the graph of the derivative. So that's kind of a neat point at this exact second. How are we going to do this? What's the derivative finding about the original? The slope. So maybe I should look at the slope of the original. Where? At the points.
Well, there's none, but you can make up some.
You can make up some. Okay, there are lots of them. They're just not specifically marked.
No.
So, like, maybe if I do that right there. So this x value over here, it's about that far from it's exactly that far from the y-axis. There we go. That x value right there should have this type of a slope. What does that tell me on the derivative? What's negative? Let's take it out of the equation right now. Be specific. Is the slope negative here?
Oh, wait, no.
I agree you should be looking at slope, not location. However, what is the slope like here? Increasing. The slope is going up. The slope is positive. The graph is increasing, I should say. So because the slope is positive here, I should be a positive height over there. So slope here is height there. Let me say that again. Slope here is like height over there. So at this x value, where your slope is positive, over there at the same x value, a very exact measuring, I should have a positive value. Okay, move farther on the graph. So let's go to this x value right here. Now let's go a little farther. Still increasing, isn't it?
Yeah.
So what should I be doing over there?
Going up higher. The dot goes up higher. Go to the next value.
Why would your dot go down? You're right, but why would your dot go down? It's not as steep. The slope is, I would say that the slope is still increasing, but it's increasing at a slower rate, so it's kind of decreasing.
In comparison to the one before.
Yes, it's a lesser slope than the one before, but it's still a positive slope. So I should be located like where here? I need to be below that point, but like where?
Not a dramatic distance, but almost like.
Not a dramatic distance. What's my boundary? Where do I not want to be located? I don't want to be located, where, like,
So why
what
is the
quadrant
dot
should I
lower?
be in? So let's see,
the
should
dot
I be
lower?
here or here? Like,
Top left.
That one.
They just find the line.
huh?
They just find the line.
The line?
You know. The line.
So
Oh, I'm a
specific.
little confused. Why is the dot below it?
Why is the dot below it? Let's do it again. Go ahead.
So is the graph going to look like a parabola?
The graph can end up looking like a parabola. Yes, it's a short answer, but let's talk about why. So your slope is positive here. It's still a positive slope here, but it's a less positive slope. You rise less for every amount that you
So
run.
you're still
there.
rising, not going down.
Correct, which is why your graph is still above the x-axis. It's still a positive location. Your height here is representative of your angle
I
of
was
your line
thinking we were
here.
like copying the graph just with dots.
So like now when it starts going down, is the graph going to go up?
Maybe. It kind of depends on where
Now.
in your graph starting to go down. So
Well,
let's say
next-
right here. Let's talk about it right there for a second.
Constant.
Slope is what? 0. My graph is constant, my slope is 0. So this slope right here is 0. What does that mean about my location at that x value on the derivative graph? On the x-axis, slope of 0 here. So my slope is 0 there. Okay. My height should be 0 at that same x value. Then what happens? So
We'll
let's
go
go past this x value.
below
So
the x.
the x value right there. On my graph, my line, my tangent line looks like that. What does that tell me about my derivative?
Gonna be below the x.
Below the x-axis derivative because your slope is negative. And by the way, it's about the same amount negative as this one is positive. So I might want to go as far below the x-axis for this x value as I am above the x-axis for that x value. Okay, so there's my x value. And I might want to go about the same amount below the x-axis as I went above the x-axis before. Okay? Why not work with the graph here, because that's kind of an interesting point where you're crossing the x-axis. A lot of people get tempted to involve that point even if it's not all that different. So what can you say about the slope here? Still negative. Has it changed how negative it is? Maybe a little bit, not tons. Okay, not tons. However, so it should still be a negative slope, but I might go a little bit lower. Okay, if anything, it's a steeper slope here than it was up here. Then what happens to my slope? So I'm gentle slope, steep, 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 steeper.
It starts to mellow out.
Starts to mellow out. So what should I be doing on that graph? Coming back up. However, my slope here at this x value would still be negative, so there I should still have a negative height, and it might be about the same negative height, so something like that. Okay. My slope at this x value is 0 again. So what should my derivative be doing? Where should my derivative be?
X.
At the x-axis on 0. Okay? And then what happens to my derivative? It starts going in the positive direction. So here I'm going to have a positive derivative. My derivative starts out gently positive and gets more and more positive, okay? More and more positive. So something like this for the derivative graph would make sense. Now, this point right here is very much not in the right spot. And that's probably because I didn't actually find derivatives. That being that height is okay. All right, it's still much higher and a much steeper slope was down here. I just didn't go quite steep enough. Kind of looks like a parabola to me. Okay. How about f prime? How about f? Double prime. So differentiate again. F double prime. Same x values. Let's talk about their y values now, or their slopes to find the derivative. So these go like this. Okay, so here I have a what kind of derivative?
Positive.
Really? you going up to the right or down to the right?
Down.
Down to the right. So therefore your slope would
The
be,
arrows that measure.
yeah, ignore the arrows then. The arrows just tell you that your graph's going to cover the whole number line. Okay? So negative slope means I should be negative on the y-axis. Okay, but at this x value, I'm negative y value. Okay, so like down there. Okay? Here, let's go at this x value. Why not? At this x value, how does that
Less
derivative change?
less than-
Less negative, but still negative. So still a negative location. I should still be below the x-axis over there because this slope is still going down to the right. It's just going down to the right less fast.
Can't it go down to the
Down to the left looks like this.
left? Okay, those came out this side.
Then that's not going toward the right, you're going down. That line is going down to the right and up to the left. Does that make sense? A line that is angled like this is going down to the right, and a line that's angled like that is going up to the right. And the arrows apparently are messing you up. All right. Where should I cross the x-axis on that graph? On the second derivative graph, where should you cross the x-axis? At 0? 0? Why?
Because the slope of f prime is 0 at 0.
Because that's where I have a horizontal tangent line. So therefore, you'd want to be at 0, 0, because you happen to have a horizontal tangent line at the y-axis on this graph, so at the x value of 0, or at least close to it. Remember, we kind of estimated from here to here. All right. Then what happens to your second derivative off of your first derivative? Okay. Then what happens? Positive. So I go above the x-axis. It's like pulling teeth all of a sudden. All right. Charlie has northern eyes quite a bit.
So it's like, oh, you go line.
Yeah. So now, this would be like the graph of x cubed. And it might have a number in front, and it might have some numbers and x's and stuff like that afterwards, but your highest power would be like x cubed here, possibly. This graph could be like what? X squared. If I differentiated x cubed, do I get an x squared? Yeah. Take the 3 down in front, multiply by what's already there, and subtract 1 from your exponent. Should leave me with some number times x to the second. And then I might have some other stuff with it. Okay? But highest power, the degree, would be x to the second if I started with x to the third. What would I get for a derivative of something with an x squared in it? Highest power or degree what? Just x. Because your 2 would come down front and multiply by the number that's already there, giving you another number. So f double prime would equal some number times x, and then it might have some other stuff with it. But its highest power would be x if you started with x cubed. So do these graphs fit those families? if I'm gonna reflect on pre-calc. In general, your derivative is graphing the slope angle here, giving you height on the derivative graph. So height on the derivative graph gives you slope angle on the original. You should be able to go forwards and backwards by the end of this chapter. Okay, so you should be able to go like from the graph of the second derivative or third derivative back to the original. Work your way back, okay, and forwards. Not right now, no. But that's coming. Okay, so that's one thing that I wanted to make sure we talked about more, because we did this when we did position, velocity, and acceleration graphs over there on that board, okay, a couple days ago, like last week. However, it may not have sunk in. Are we good on that? Yes.
From the third derivative to the fourth derivative.
Yep.
Does it go from a positive y value horizontal line to one on origin?
No.
No, it doesn't.
For this third derivative?
From the third to the fourth.
Oh, yes. It would go from a horizontal positive line, so positive height, horizontal line, because I have a constant slope, but it's a positive value. So my third derivative would look like that. And my fourth derivative would be on the x-axis because it would be a constant slope of 0. Yes. Eventually, Cody, this is good. Eventually, all polynomials, if you differentiate them enough, eventually their derivatives will be 0.
So they'll all be
Still 0. So the derivative of 0 is 0. And the slope of a line on the x-axis is still going to be,
So then the fourth one would be 0, the fifth one would be
and every one after that, yes, because the slope is still going to be a constant 0 after that. All right. That's one thing. Here's another thing. These are not graphing oriented anymore.
We have to do something that's
Yeah, it's fair game.
So wait, we have to be able to like do graphs and we just did.
Okay, so you're not going to be graphing for me. You'll have graphs and you might have to match them, like you've been doing in your homework. You had a few problems in your homework a couple nights ago where you actually had to say which one's the derivative of which other one.
That one?
I don't know if it was on that one or the one before it. But it was on page 126 to 128-ish, yeah. But it might be the section before that.
Is that the one that's not with this?
This week. Could be from last week's. I think it was from last week, but it might be this week's. We're going slower than originally planned. It was supposed to be on section, it's in section 2.2 or 2.3. I think it's in 2.3 that they have you do it. Okay. So let me start you off with a different kind of problem. F of x, let's say that f of, I'm not going to give you f of x. Let's say I just give you specific things about f of x. So let's say I tell you f of 3 is 10, f prime of 3 is -2, g of 4, wait, what am I doing? G of 3 is 4 is what I meant to say. And g prime of 3 equals 1. And I want to know what is h of 3 if h of x, h prime of 3, if h of x equals f of x times g of x.
So you want to know.
Find h
okay.
prime of 3 if h of x equals f of x times g of x, and you have this information. Okay, so in theory, I know that I need h prime of 3. That requires me to find h prime of x, right? If I need h prime of a number, a number plugged in, don't I need h prime to plug that number into? So now, yeah, I know we have h. So how can we find h prime from h? What is h prime? The derivative of h, right? H prime is the derivative of h. So I need to differentiate h. So how do I take the derivative of f of x times g of x? How do I take the derivative of f of x times g of x?
Take the first one times the derivative of the second.
Thank you. Product rule. So you're going to do the first one times the derivative of the second one. So f of x times g prime of x plus g of x times f prime of x. Now I need to find h prime. I can't really do anything with that because I don't know what f prime, f, g, and g prime are, but I know what they are at 3, and I'm asked to find h prime of 3. Maybe that's related. So if I need to find h prime of 3, and I have h prime of x, what do I need to do? Substitute 3 in for all my x's. So this is h prime of 3 will equal f of 3 times g prime of 3 plus g of 3 times f prime of 3.
Oh.
What's f of 3?
10.
Hey, 10. What's g prime of 3?
1.
1. Plus, what's g of 3? Or, yeah, what's g of 3? 4. Times, what's f prime of 3? What do I get?
2. Oh, well, you get 10 plus anyway.
Yeah, that's 2. Just the product rule. The only thing we did. But we applied the product rule. And all your knowledge of function notation for pre-calc. Want another one?
No. Yeah.
Yeah.
Do one with like a.
That's why it should also
Do one with like a Z in it.
Use those same F. Let's not change those. Let's keep those the same. Let me just make a new H of X. So find
A's and B's in there.
A's and B's. That doesn't sound like fun. Find H prime of 3 if H of X equals 2F of X plus G of X. Okay? So to find H prime of 3, I probably need what? H prime of X. Find H prime of 3, I probably need H prime of X. So if H of X equals 2F of X plus G of X, what's H prime of X going to be? Differentiate. How do I differentiate 2 times F of X? Good.
Plus
Hang on.
F of X.
2 times F prime of X. The constant multiple out in front stays. Constant multiple out in front multiplied by the derivative of the other guy.
And just be plus F of X.
Plus,
Just add F of X.
oh, you're going to do the product rule? First times the derivative of the second,
And then F of X.
plus F of X times the derivative of 2. What's the derivative of 2? So do I need to write F of X times 0? Okay, the constant multiple
I
out
was
in
thinking
front.
it was like 1.
But that, you just justified why a constant multiple can stay in front of the derivative, and it does get differentiated, it just turns to a derivative of 0. So the second part of your product rule is gone. He used the product rule for a second. So he thought of 2 as the first thing, f of x is the second thing. So he said first times the derivative of the second, so 2 times the derivative of f of x, plus he did f of x times the derivative of the first. And the derivative of 2 is what? And f of x times 0 is, guess what? So you get 2 times f prime of x. But we still haven't differentiated adding g of x. How do I add the derivative of g of x to that? What's the derivative of g of x? G prime of x. G prime of x. Okay? So really I have 2f prime of x plus g prime of x. So you don't need the product rule technically for this one because it was a constant times f of x. Okay, so h prime of 3 is going to equal 2 times f prime of 3 plus g prime of 3. So 2 times f prime of 3 is negative 2 plus g prime of 3 is 1. G of 3 would be 4. G prime of 3 would be 1. And that brings up a good point, though. You got to be careful which one you're plugging in. All right? Negative 4 plus 1 gives me negative 3. Does that make sense?
Yeah, oh yeah.
I know. You just looked at the wrong one. You got to be careful. And you have to make sure that you don't drop any of your primes that are supposed to be there, but don't put them where they're not supposed to be either. You know, like we got to make sure we know the product and quotient rules and when we need them. Okay.
Okay.
No. Huh? Yep. Try this one. No. To time. Should just take the quiz now. No. This is a catch-all. All right.
So what do you think of the bakewell?
If y equals 5x squared plus 3x, prove, all right, if y equals 5x squared plus minus 3x, prove that works in x times y prime minus x squared times y double prime.
Wait. What is
Plus 3x equals 0. Prove that this y equals equation satisfies that.
what is that?
That's what I'm giving you. I'm giving you these two things and saying prove that this works in that.
So
Oh, that's easy. Why?
You just find the prime of y.
what is
Plug them into that and then find another prime of y.
Okay, x, it doesn't matter what x is because what this says is I should be able to simplify this side with a specific y prime and y double prime and equal 0. And if that doesn't happen, then I've probably done something wrong. So y prime, I need y prime for that equation. So what is y prime? 10x minus 3. I need y double prime also. What's y double prime? 10. Remember, folks, you have not only the power rule, but also the product rule and the quotient rule. Your original y equation could require you to use any of the rules you've learned. Okay, so these can get more difficult because you could have more difficult derivatives. However, now I need to rewrite this thing with y prime and y double prime and y, if needed, in it.
And they all cancel out.
So x times, what's y prime?
10x minus
10x minus 3. Probably need some parentheses around that. Minus x squared times what's y double prime? 10. And then plus 3x equals 0. You have to replace the y prime and y double prime in this equation with what they are actually equal to. Distribute your x. 10x squared minus 3x. Minus x squared times 10 is 10x squared plus 3x. Does that equal 0?
Yep.
Yeah. All right, come on. You just verified that this satisfies the differential equation. That's other wording. Ready? So instead of saying prove, I could say verify this differential equation. That's other words for the same exact thing. Verifying means prove. Okay? A differential equation is something that involves the derivative, and we've involved the derivative and the second derivative. This is a differential equation. Okay? All right. So at this point, I'm going to give you review problems that I would recommend you do as much or as little of as you want. I'll even say it that way since there's a limited amount of time left. Here you go.
Wait, you said we have to do.
Oh my God.
Do I need to say you need to do all of it for you to do as much of it as you need to do?
So you want.
He said do as much of it as
More homework.
You don't know it, you're going to do it all. If you know it, you don't have to.
That means we're not getting homework tomorrow.
That means we're not doing the chain rule today, and we will hope to do it tomorrow. We'll see.
You'll get an A plus on the test tomorrow without doing it, and you don't have to. You will get an A plus, and you have to.
Are we just working on homework now?
Oh my gosh.
Yes.
I quit.
No, it's just some random.
I said it twice, and I'll say it again. It is as much or as little of that as you need to do. Do it. You have a quiz tomorrow, and that is a review assignment. It is not new. So what I would do on that assignment is I would look at each of the problems. I would at minimum do one problem from each section of directions, at minimum.
Wait, so it's not turned in.
This is not one of your homework assignments that's going to be due on Monday.
Ah,
Do you want me to?
Yes, press stop.
need to review.